In response to an infectious disease outbreak, it needs to be decided whether existing control measures are sufficient or need to be strengthened. To help inform such decisions, one statistic to consider is the growth rate. But what is the growth rate? What are reasonable modelling approaches for estimating the growth rate, which can also be used in real time as a tool to help inform public health policy? How were these approaches used to study growth rates of SARS-CoV-2 for small local populations in England? We explore these questions and more in this episode of SBIDER Presents.
This is SBIDER Presents, a series produced by the SBIDER Podcast Hub. My name is Laura Guzmán.
And mine is Ed Hill.
During this episode, we will be discussing the research article Bayesian estimation of real-time epidemic growth rates using Gaussian processes, local dynamics of SARS-CoV-2 in England. The article was published in Royal Statistical Society Series C, Applied Statistics in June 2023. This work, which I led, was a reflective account of work done as part of the modelling response to the COVID-19 pandemic. Outputs of this work were discussed on a routine basis during the pandemic and are now incorporated in the UK Health Security Agency surveillance toolkits.
Now some time has passed since the work was done, we hope during our conversation to share reflections on how the work was used at the time. We will also delve into how it may be built upon as part of public health disease outbreak response plans and pandemic preparedness strategies. So this is a bit of a different episode today, so it's a chat just between myself and Laura about the work, Laura, which you led, as you just described, back in 2021, and it was recently published. To kind of give context to the listeners, what was the context at the time and what was the motivation behind this work?
Hi Ed, and it's great to be on the other side of the table. The project started at the beginning of 2021 because I just finished my PhD, and we were in the middle of the pandemic, and at that time I started this position with the Juniper Consortium that we might have mentioned them before in these episodes. So at that time I imagined that a lot of questions were emerging around the pandemic, and the more people that join and try to answer these questions from a quantitative point of view, the better. So I joined this consortium that their goal was to provide quantitative advice in response to the pandemic. So basically that was the context at that time for me. I'm just starting this new position, and what can I do to help? But what was the context for you as well, because you were involved in this project too?
That's right. So thinking back to that early 2021 period, at that time I was 100% funded as a postdoctoral researcher on a medical research council grant to essentially help aid the modelling response to the COVID-19 pandemic. So I think that funding began around mid-2020 and it was 12 months funding. So my job was 100% to work on problems associated with COVID-19 modelling, and therefore as part of that role within the SBIDER group, and then through when the Juniper Consortium began, and we had people hired in postdoc positions related to that consortium, like yourself, and then there were a couple of others in the Warwick group. I was then involved in basically the meetings, discussions you were having with the work you each began and worked on at that time. So that's how I became involved in a collaborator type position with this work. Given that context, what was the question that we were hoping to help address at that time?
Good. So when I started, as I mentioned, there were a long list of questions that needed approaching. And one of those questions were saying, what is the impact of interventions? And one of the ways to analyze the impact of interventions was to try to understand what's going on today and what's going to change if we put an intervention on. So that basically needed us to create a way of measuring if things were changing or not. Of course, that wasn't at the end what I did. It moved towards something else. It focused way more on measuring how things are. That was even a simpler question, let's say, because it was important to quantify if things are growing or not. And then, of course, at that time and in research in general, there are a lot of ways of measuring and approaching this question. And one of the usual common statistics that are used is called the reproduction number. And we've heard it a lot here. It's a very common, well-known quantity. And then I also heard some other thoughts about other measures. And since it's an emergency situation, I think every new thoughts are welcome, and there is more focus of everyone on work on these new ideas. I took on these ideas of growth rates, and I started working on those ones because, a difference to the reproduction number, growth rates have different assumptions, more statistical assumptions, and less about the behavior of the virus, about how long it takes the virus to come from one infected person to another, and these questions that are already very hard to answer. So approaching the problem from the growth rate perspective was great. And that's what I ended up not answering, but approaching.
I think you highlight there how we might begin with, it'll be good or interesting to explore a certain question, but then we realize, oh wait, there's certain knowledge we need to actually be able to reasonably address that question. So actually there's this prior question we need to think about. Then the next step, given we've now defined a question, so were there novel methods or developments that needed to be made to be able to, say, estimate the growth rate of the epidemic, or in this case, SARS-CoV-2?
The growth rate is, of course, not a new concept. It's been around in many fields. And I should mention that the growth rate here, we define it as kind of the rate of change of the number of cases in this context. So there are a lot of approaches, and they can come as simple as fitting a curve, like an exponential curve, for example. I don't want to go into technical details, but it can be very simple. And again, in the context of the pandemic, a lot of new ideas are very welcome, because the different the approaches, the more things we might see that we weren't seeing with other ones. So even though there are methods existing, it's good to have these new ones that can be adapted to the situation, to the flow of data we were having, because we had time series that were coming on constantly. So in that way, new approaches were very welcome. And as I mentioned, I finished my PhD just before, and during that project I did there, I was working with Bayesian models, and I ended up using a mathematical object called Gaussian process in these models. And I was using it in the context of genetics. But I had this background knowledge here. So I thought that knowing that tool already was quite useful, and I could see that I could incorporate it into these questions that we were trying to answer. And as I mentioned before, we didn't have to make strong assumptions about how the virus transmits in terms of time. For example, we were trying to just compute that rate of change, and the Gaussian process methods ended up being very useful. And then we could capture some underlying pattern behind the data we were observing.
It really shows the usefulness of having a range of different approaches being thought about, because then each approach, there can be differing level of, say, complexity required. So in this case, you're not having to make any assumptions about, say, how fast the virus is spreading from one person to another. In some other model setups, things are kind of very explicit. So there's like explicit equations for what's the amount of people in a certain disease category, and therefore that requires more information to inform, so what is the rate from going from one disease state to the next. And then by using a range of different modeling approaches, then that can then help see if we get a consensus across them, or if there is differences in outcomes, then that highlights something that's of interest that should be explored further to try to understand why these differences are occurring. In the instance of this type of model, the fact it's being used in a real-time response type setting, it's like the speed, the amount of information it needs to be able to run is perhaps less compared to some other models, and then that's an advantage in this quite fast-paced situation.
Yeah, and actually, one of the things that I was really surprised about here was that idea that mixing different approaches It sounds, if you all are trying to answer the same question, what are you expecting to get the same answers? And actually, it's in the differences of these answers that we got so many interesting things to explore. And that point you are mentioning, it's so true. It was incredible how the more the merrier in a way.
What were the key findings, and were there any which were unexpected or surprising?
The outputs of the study in general was a set of tools with the goal of estimating the growth rate at a real time, in a retrospective way, or what's happening today. So we got two versions of the model, and each version depended on the amount of data, the kind of data we have. So if we are, for example, having information of the number of cases, then we had a model that could try to see the changes in cases looking only at this stream of data. But if you, for example, have also the amount of tests you did to get that number of cases, we could incorporate that in a second model, and that helps us also if, for example, there is a massive increase in testing, you might see a bigger increase in positives because you are trying to look at more people. So the second method we developed was focused on trying to capture that changes incorporated in the testing data. So the output were two versions of the model. One for only looking at cases and one for looking at cases and tests. And with this package, we were using it worked fast. So we were using it on a routine basis, and we were running it, looking at cases in England on a weekly basis. And then we also realized if it's fast, and if we had such a big volume of data, we can look at not the whole England, but lower resolution regions. And in England, there are around 300 smaller regions called local authorities. So we were looking individually at all of them, independently, and then trying to see if the signal we were picking up was differing in some places. Are the cases growing more somewhere, or is there a location in particular that is growing way more than their neighbors? Or also we started, instead of looking at cases, we were only looking at a variant in particular and trying to see, is it growing fast? Is it growing faster than the previous variant that was dominating? So is this an indicator that this new variant might have some advantage over the previous ones? So we ended up realizing that this pack of tools were very flexible, and we could adapt it depending on the stream of data we had available and the questions that were being asked. About the surprise, I think I mentioned something that surprised me a lot, and it was the advantage of working at the same time, answering the same questions with different people, and everyone making their own assumptions. And then we found so many different things. I think that was so surprising and amazing at the same time.
And I strongly agree with then just seeing day by day the amount of work just being done by the various groups, and then that bit all being pulled together and consensus views arising, and then if there was discrepancies, discussion about why that might be occurring. Given the work being done, and now also with some time for reflection, so from your perspective, what were the perhaps main implications of these findings, perhaps at the time, and then also given the limitations, as with any model, there are certain assumptions, limitations with them. Are there anything that we should bear in mind, and are there things therefore that it will be good to keep working on and address in the future?
I think the implications were, we mentioned how important they were as an emergency that is ongoing. So I think the implications were very big as we were giving some evidence in a routine basis of what's going on. And also we use these methods in other countries as well. And so later I joined a position with the Cambridge Wellcome Trust, and I used these same methodologies with their streams of data, not only on COVID, but in other diseases. And it showed that it's useful as well, that we can pick up signals from it.
And that collaboration with Cambridge Wellcome Trust, so is that based in Kenya? Is that the region that work was applied to?
Yes, of course I was joined through the University of Warwick, but my colleagues were all in Kenya, based in Kenya, and they had their own access to the main questions that were happening there. So we found out this was useful to use these same tools in that project.
Again, that's really cool to see how the generalizability of the method in other disease outbreak contexts, other geographical contexts.
Yeah, and it's good to mention how general it is, in the sense that it leads me to talk about the limitations. So when I am talking about these models, I say how this is a practical tool that can be used in many circumstances, but also that also makes me think that as every model, these models have assumptions, and these assumptions rely a lot on the data you are having. So I think the limitation, I would say, is just that we need to be careful when we use it, in the sense that we need to be conscious that the data might have their own particularities. What is the source of the noise that we are having? And the framework we have is flexible enough so you can add and remove things, but you have to be sure you know what are you adding or removing. In the case of England, we were using day of the week effects, but you can adapt it depending if you have other types of data, like weekly data. You have some prior information that you can incorporate to the parameters of the model that is very useful as well. So I think my limitation would be more like it needs to be carefully used and not like an automatic tool necessarily. It is ready to use, but just keep in mind what the assumptions are behind, because it can lead you to wrong ideas from your data.
I think that's really great insight, and it's always useful to consider what is the research question that we're looking to answer, and then is the methodology appropriate? And given the data available too. So given the data available and the methodology, is that appropriate to try to help investigate the question that's been posed, the question we would like to be studying? And so lastly, what in your view do you consider to be the key challenges for using these type of models, methods in future disease outbreaks?
I think it's good to know the methods exist. I would say two things. First, we want them to be easy to use, to be ready to use, but that comes with a second challenge. We want it to be ready to use, but at the same time to be careful, as I mentioned before. So I think the challenge is to have a ready-to-use software that you can access to it. It doesn't matter, you don't need to have programming skills. But at the same time, you know how to play with the tool so you can incorporate the assumptions you have about your data. So as I say, you don't just use it as an automatic tool where you cannot interact with it. So, I mean, I'm saying this as a challenge, but in reality it's like an opportunity. And actually we are working on that software now, because we are aware that when you are in an emergency, you rather have something you can use quickly, especially if you are waiting for more complex, maybe more biology-based methods to grow. And while they are growing, we need something that works fast and doesn't require you to know R or C++ or any of these languages, so you can actually just jump in and use it quickly. And that is what we're working on right now, but always being careful that we leave it flexible enough that you can interact with it.
I think that'll be a tremendous addition to the toolkit for those who are looking to help answer these public health related questions. So that's really cool to hear.
Ideally it should be done by next year. We'll see if that happens. Excellent.
So we should keep a lookout for that. Thank you so much, Laura, for sharing your reflections and more about that piece of work. There was a lot happening at the time, given the situation, but I think the work carried out was immense, and it was very helpful and great fun to collaborate with you on this project.
Thanks, Ed, and thank you for all the discussion. It's always very nice to talk about it. And also thank you for taking that side of the table to ask the questions.
And with that, thank you all for listening to this episode of SBIDER Presents, and we hope you will join us again next time.